All right, guys, so let's continue with simplifying or rearranging our equations. Up here, they tell me that I want to solve for x, which means I need to get everything away from my x. What is not x is the 6, so we need to move it away. And how do we move the 6? Well, we have to undo whatever is being done currently, which currently we are multiplying, and we know the opposite of multiplication is division. So we divide on both sides. Our 6's cancel on the right, and I am left with g divided by 6 equals x. Now, ladies and gentlemen, this is where we stop. You do not need to solve for g or solve for x. We can't without knowing one or the other. So my answer would be g divided by 6. When we move on to the next one, again, we are solving for x, so I want it to say x equals. I need to get everything away from my x, which means the first thing I personally want to move is my -2, because it's easier to move stuff that is not connected to the x first. So first we go with addition and subtraction. And the opposite of subtraction is addition, so we plus 2 on each side. These 2's cancel out, and I now have u plus 2 equals 2x. And now I want to move my 2, so I move it with division, because again, it's multiplied together, and to undo multiplication, we divide. So we have 2 to 3 different answers we could write depending on which one you like best. We could say u plus 2 divided by 2, not x. We could also break these up into individual fractions, so we would have u divided by 2 plus 2 divided by 2. And we know 2 divided by 2 gives me 1. All of these equal x. And again, that is where we stop. That is the final answer. There is nothing else we can do because we do not know what does u equal or what does x equal. Number 3. Again, I want to solve for x. We could do this 2 different ways, and I will show you both of them. First way is the simple way, saying move everything away from my x, which means first we need to move our m. Since this is a positive m or a plus m, we need to subtract m on each side. Our m's cancel, and we get z minus m equals negative x. Now we need to get rid of that negative sign. Technically, this says -1 times x. And because of that, I need to, we could either divide or multiply. It'll be the same thing. I'm going to multiply each side again by -1. So my negatives are going to cancel. And over here, I would have negative z, because we're distributing, plus m equals x. We changed the signs on the left. The other way we could have done this, I'm going to rewrite the problem. I don't want a negative x. We learned that at the end. So what I'm going to do is actually move x over to the left. So now it will be positive. So to undo minus x, we plus x, and we plus x on each side. So we have z plus x equals m. And now we move the z to the other side with subtraction, because again, this is technically a plus z. And when I move my z, I get x equals m minus z. Both of these are correct. The first way is just written in a different order. I prefer to do the second way. I like to always keep my x positive, which is why I would prefer to move x over and then z over. Because when we do multiplication with a negative, we typically screw up on a sign. So let's come over to number 4. Number 4. We want to solve for A, so I want my A by itself, which means we need to move C. And when we move it, we have to divide. And we are dividing because A and C are multiplied together. And to undo multiplication, we use division. So these cancel, and I'm left with G divided by C equals A. Let's skip to a slightly more difficult one. Let's do number 10. Number 10, again, we are solving for X. First thing we need to do is move our 2 over to the other side. You also could choose to move 3x over here if you wanted, but since it has a 3 in front, I'm going to choose to leave it. So we move our 2c over with subtraction because it is a positive number. Our 2c's cancel on the left, and I'm left with negative 3x equals negative 3 minus 2c. And again, we can leave the c where it is. We don't need to touch it because I'm not trying to move my c anymore. I need to move this negative 3 though, and since it is multiplied together, we will divide on each side. Our 3's and our negatives cancel. We are left with x equals negative 3 over 2, or minus 2c minus 3. And similar to the other problem, the one that we did earlier, we can rewrite this. This would be negative 3 divided by negative 3 minus 2c divided by negative 3. I'm going to put a plus sign in the middle so I know I need to add them together. They're not the same. And when I do that, I notice, hey, my 3's are going to cancel out. Negative 3 divided by negative 3 gives me 1. And I have a negative divided by another negative, which will become a positive. So we'll have 2c over 3. So my answer would be 1 plus 2c divided by 3. Or you could leave it this way. Let's find another one. Let's solve 20. This one looks a little fun, a little difficult. So let's go ahead and solve this one. We need to move our a to the other side, or we can move this to the other side because we want to solve for a. I'm going to choose to move the top half over, and we know that if it's a fraction, we need to flip it upside down. So this time we are going to multiply by 1 over 1 plus 2a. And then my top of my fraction and my bottom fraction will cancel out. And over here, I'm going to do the same thing. So I have 1 over 1 plus 2a. My g will go on top. So I'll have g divided by 1 plus 2a equals the fraction. And now, we're actually just not going to do this one because that goes into different parts that we don't care about right now. So eventually we'll learn stuff like that, but we don't need to right now. Same thing with like 21. 21, we're not going to do that because it looks a little bit too difficult and scary for us right now. So we're going to keep going. Let's see if there's one more we can do for a final example. Let's choose 28. 28 looks really confusing. And we are solving for a. So I want this letter all by herself or his self. I want it by itself. First thing I want to do is see what is added or subtracted, and that's what I want to move. So this negative 3, we're going to boot over to the other side using addition. My negative 3 and positive 3 will cancel out. I will have negative 3a equals negative 2n plus 3p plus 3. And then again, I'm going to divide by negative 3 on each side. And as I look at this problem, I notice I have a negative divided by negative, so my negatives are going to cancel. I have a 3 divided by 3, so my 3's are going to cancel, and I have a 3 divided by 3, so my 3's are going to cancel. So I end up with A equals, we canceled out our negatives, so we just have 2n divided by 3. Over here, our 3's canceled, so we were left with a 1p, and remember that 1p is negative. So I'm left with minus p. And over here again, my 3's canceled out, but I do still have that negative sign. So minus 1.